Hello there. In this video I will be revising the debug console on this board. So I have started bringing up another board here, just making sure that all the latest stuff that I've added to this board also works on this board. I can clearly see that certain things are not really working, but it's kind of hard for me to separate all of the errors from normal messages in the debug console. So I want to improve this startup output a little bit. And two of the basic things that I'm going to do is add messages to the driver code that will output which driver it is actually probing. And I'll also add colors to any errors that I'll be printing to this console. I think that using a debug console is a very nice way to debug an embedded board. You can easily add commands to the debug console. You can debug different peripherals connected to the board. For example, here I have several commands that are registered by the device drivers of this board, and I can debug the low-level stuff that is going on inside those chips quite easily by just adding new commands that allow me to do that. But when it comes to debugging the startup, one of the ways I use is I fire up GDB and I check where the program has stopped. But I also find that having a detailed printout of what has been going on is very helpful besides using GDB, because certain things you may see, like for example, something may have failed but didn't fail hard enough for it to be an actual crash, and then your program crashes somewhere else. And if you have that printout, it's easy to see what went wrong during the startup of the program. So one of the first things I'm going to add is the colors to the output here. So the way I was thinking to do this actually was to just go to the console interface. Let's see if I have it in the console interface. Or actually, I think I have it in the serial interface. So I have this serial printf. Where is it? The console device there. And let's see. Where do I have print K? Let's see. I probably have it in the driver header. Yep. So I'm just going to add a few defines here. Define. Info would be white color. And I'm just going to have a look what the code looks like. So BT100 terminal colors. Let's see. Oh, there's colors. So white would be 37 for foreground and 47 for background. And then there is a code that we run that looks like this. Let's see. So normal would be 3047, which is black on the foreground, white on the background. And then I will have red for so it's going to be 31. $39.49. Okay, cool. And this string will be x0b. Let's see. I think it's 0b. 0b would be the escape character, and then I have this opening bracket, and this would be 0m. So this will just reset everything. This would be 31, I think. Yeah. 31M. And print. What else could I use here? White, red, green, 32. Yeah, for now it's just enough to have info and error. And then in my printf, or print k in this case, here I will just do like this. Ten is just sort of the default timeout that I use for print k. And then I can go to this driver for the encoder, so MAX14890, which outputs here there's a fault status, so the chip is actually unreachable. These two chips have had problems with being reachable. I think that when I've been soldering them, there's probably some pins that didn't really solder properly. So let's see. Where could I have this chip? Let's see. I can just write this definition right in front of the text. that happens sometimes if the chip is unreachable when ST-Link is plugged in, so I have to unplug the ST-Link and plug it in again. And this was not really working. Yeah, was it 0B? Did I get this completely wrong? What is the escape sequence? One B. Okay. Yeah. And there we go. So now it's much easier to see what has failed and what has succeeded, because as long as I use those prefixes. So that's one way of doing it. Okay, now I need to find out why this chip is not reachable. So what I'm going to do is I'm going to try to unsolder it. Okay, let's see if we can get at least one of them working. So there's two chips. One is here and one is on the other side. And because I've been soldering this board myself, it's a common issue that maybe one pin is not connected, and that could affect communication with the whole chip. Okay. Yeah, it definitely looks like several pins on one side have been unconnected. So I'll resolder this chip and then we'll try again. And what I'm also going to do is remove the solder mask from the ground pad, which is one error that I did on the footprint. I did not uncheck solder mask from this pad that I've created. So the pad is covered with solder mask. Now the datasheet says that it doesn't really matter, that EP is just for sort of leading away the heat, but I think it does matter. There is something that, like, when I scratched the solder mask from the ground pads of the other two chips on the other board, they started working. So there's something about this ground pad that does require that it connects to ground. Put a bit too much solder on it. Okay, and then I'll just solder this back on. Not melting yet. A little bit. Alright, seems to be soldered. Wait for it to cool down a little bit and then try it out. I need this chip to work on this board because for the next step I will need to connect motors to this board, and then I'm going to have a CAN connection. I'm going to be implementing the CAN interface, and then I want to have the CAN connection going from this board to this board. So this board will control this board, and the motors, the servos. Here's one servo, and there's another one behind here. This one is a cylinder, a linear actuator, and this one is a geared servo. I'm going to be controlling them with this control interface here, and they'll be connected to this board, and the control will be going over CAN open. So I need to have this encoder interface working. Okay. Time to see if it works. I think what happened was that something happened to the LEDs. Does this one need to be resoldered as well? So the software cannot communicate with the LEDs driver. My IGC driver is really simple right now. When the communication cannot be established, it just hangs. And yes, I know that I shouldn't be using any while loops anyway, but it was easy to get going. It's kind of, it just works. It's very simple. Could it be that I've introduced it? That could be the case. Maybe the peripheral power supply is shorted. Because I have different power supplies, one for CPU and one for peripherals. And some peripherals, let's see. I wonder if MCP 2317 is actually working. No. 5 volts. It's stuck in LP. Oh, that's nice to know. LP55231, and that is yeah, it's the LED driver. So something is screwed up with the LED driver. So I powered off the board, so I cannot step in the debugger anymore. Does it have a reset signal? I'm going to check the enable line. It actually started now. Okay. Okay, so the MAX14890 is actually working, but there's still some problem with I2C. Maybe I'll figure it out as I debug this a little bit more. It could be related to some I2C device not really behaving well. Maybe I would need to reset I2C bus manually. So by just toggling the GPIO pins manually and just resetting every single device, if this problem persists. Okay, so now I have the other one. I fixed this chip. And now I have this chip to fix. Let's see if I can do this without melting the wires. Fantastic quality of custom soldered boards. I've got a few boards coming from the factory, probably sometime next week. I'm very excited about that. But now I have large portions of the software already done, because I soldered this manually, so this was a win anyway, even though it takes some time to debug things like this. And even though it looks like the board is connected to the serial interface, it actually isn't connected. The power isn't connected. So it's just ground and signal. Okay, these are removed. And it looks like maybe, yeah, a few pins again. Same problem like on the other board. A few pins that are not any solder on them. I'm going to distribute the solder manually and then solder it back on. Okay. I'm going to remove the solder mask, just like I did on the other chip. Removing the solder mask from the ground pad, which according to the datasheet does not need to be connected to ground. But apparently there is some purpose in connecting it to ground. Or maybe it's just the pins that are not connected. Oops. So Put a little bit of solder on all of the pads, the footprint. And it's time to solder. Okay, this was a bad idea not to have a fume extractor running. There's a lot of smoke. Almost done. Is this gonna work? Hello, Damien. How did it go with your boards? Did you get any of them running? The weather station boards. Okay, I'm gonna try this out. I think it's pretty cold. Cools down very fast. Nope, still not. Still unreachable. Maybe this chip is. Let's see. I have to use a microscope. Looks like it's seated. It's not the cleanest solder job, but it's nonetheless it looks like it's seated. So where is the problem? Oh, it's actually a little bit lifted from the surface, I think. Where's the text pointing? That's a dog hair. Everything sticks to the boards. Where's the dog hair? There it is. Everything sticks to the flux. dog hair is stuck. Dog hair is soldered to a capacitor. There we go. Awesome. Okay, so I kind of find it hard to see whether the text is properly rotated. Because like when the chip has flux on it, it's very hard to see the text. Okay. So the text is pointing that way. Let's see. Can we see where the pin marker is? And the pin marker should be here. Is this where the pin marker is? Where's the pin marker? It should be there, so it seems that it's correct. Yeah, this is the pin marker. I'm going to make the pin marker a bit bigger for an extra revision. Because even the factory had trouble figuring out what the pin marker is. First pin marker. Okay. Time to heat it up again. Nice. So do you want to share your idea of why I didn't have the waveform in pulse view? Kind of seems like the solder mask that's on the ground pad is lifting the package a little bit from the PCB, so some of the pins don't actually make very good contact. Okay, I'm going to try to press it in and remove the heat. Maybe this will work better. It looks soldered, but that doesn't guarantee that it actually is soldered. Okay, it's time to see if this chip works. Nope, it doesn't work. Okay, what about the enable pin? Maybe it's the enable pin. Let's see. Does it have any enable pin? Is there anything that I could check here? Maybe it isn't getting any SPI signals. And this one is U24, that's not working. So I could check the signals on R79 and R122, and then just moving on here. So checking on R79. Checking on R122. Nothing? Or, yeah, something, but doesn't look very good. Master out, slave in. So it doesn't look like it's actually getting anything here. So the output is actually just basically high. So if I connect the ground, right now I didn't have the ground connected, so I get a little bit weird signal. If I connect the ground, I still get that kind of crap. So this is definitely not really working. So that would be the MISO. And is the chip select working? Where is the chip select? There. Pin number 5 on this side. The chip select seems to be low. Is chip select low? Maybe, actually, but what's happening is it could be that the chip select is simply not really connected here, and that's why we're not getting anything. So the data that is being read, that's from a different chip, so that's from the GPIO. So therefore, this chip select isn't actually toggled, but it still should be high, because if it's not high, then this chip is technically selected, unless I'm just not getting contact with the chip select pin. It seems like there is nothing there. Because this one, I do get contact. Chip select, no contact. And then the other ones, which do seem to be working. Okay, so chip select on this pin here. Let's see. Chip select is on. So where is it connected on the CPU? Let's see. So I could check if this pin is properly soldered. And is it actually even signaling anything there? So this would be the fourth trace from the side here. So now, touching on the MCU pin, it seems to be low, which leads me to believe that maybe I forgot to configure it, because I had the same problem on the other board, and I didn't bother really looking into it until now. So maybe I just didn't configure the pin. I'm gonna check my device tree, and this would be pin number. Let's see. CS2. PD15. So let's see if PD15 is configured. Probably not. I'm going to see where I have the NCS1 configured, PD4. So, do like this, pin 4. PD4. Got PD4 there, but then I don't have anything for the... Or actually, yes, I do have it. PD14. No, PD15. God damn it. Of course. So maybe I just didn't have the CS pin. That would explain why the driver cannot communicate with the chip. Let's see. And it's still not working. PD15. Did I actually specify? Yeah. Defaults 1. PD15. Yeah, that's the only place where PD15 is configured. So I'm going to check if this is high right now. I'm going to bring up the scope here. So, checking PD15. Yep, looks like it's high. The pin is working now. So the problem is probably something else. But at least I'm one step closer. So CS is working now. Yep. And what about I'm gonna check if I get any signal when the board starts. Let's see. Yeah, there's definitely something. So this was on, I think this was, let's see, I'm going to check what pin it is. This was master in, slave out. So the chip was actually responding. But something else is not right. Maybe I misconfigured the, I don't know. It should be fine. It should be, it's exactly the same pins as the other chip. So the only thing that was not the same was the CS pin. But why is it not working? So I'm gonna check the clock now. I mean, it could be that it was another chip just responding, because even though there are resistors, it could actually still be some other chip that responds. But we do see the signal from the other chips, but it's kind of like it's not going all the way down to 0. So it's kind of hard to tell whether the only way to tell would be to remove the resistor and to check if it's actually this chip that's responding. I'm going to check if I have power here. So I should have 5 volts there. 23. That's the SPI. Yeah, maybe the SPI pin is not connected. That's worth checking. Let's see here. I'll pull up the... Oh, look at that. So it was the SPI pin. When I'm holding my scope there, I get a connection, so it's actually communicating over SPI. So that was it. I found the problem, so I just need to solder this a little bit better. I'm going to turn off the board, and I'm going to just grab my soldering iron, the normal one, without using any hot air, and I'm just going to hold it close to that pin to make sure that the pin gets soldered. And hopefully I should be able to start the board and get both chips working. So the SPI pin places this particular chip into SPI mode, otherwise it's parallel mode. So it's pretty important to have the SPI pin working. Nope, not yet. Let's see. Yay! Now it's working. Alright, thanks for watching, and I hope you learned something. Hope you learned something about debugging the SPI ports and the I2C ports.